Welcome. In this video, we will take a deep dive into the automated migration of SAP HANA database to Azure. While the demo in the latter part of this video is focused on migrating to Azure, please keep in mind that this automation solution can also be used to migrate SAP HANA to other cloud platforms such as AWS and GCP. By the end of this video, you will be familiarized with how the automation transpired using IT-Conductor. But first, let's take a look at why you need to automate this migration scenario in the first place. Migrating databases in general is time-consuming. It involves gathering information about the source and target environment, evaluating whether they are compatible or not, building the infrastructure of the target environment, installing the application and the database there. Now, imagine doing them all manually, not to mention the need to replicate or back up your data before actually moving them. Sure, it can be done. The question now is, how long would it take you? How complex would it be? Especially for large organizations, locating various databases would be a challenging task if your database schema is outdated. That means your data are just all over the place. Failure to perform data migration accurately would be a big risk for you as a business. Aside from the deployment cost, which is, by the way, the biggest barrier for some, your organization is at risk of losing millions, even billions, if you lose a chunk of data critical to your business. With all those in mind, we have come to set forth and develop a solution that will not only simplify your data migration process, but also save you from the burden of losing data, money, and time. Before I proceed, it is also important for you to understand that there are two different options that you can use to move your SAP HANA database to Azure. These two are the asynchronous replication and the backup and restore. Asynchronous replication uses SAP's built-in tool itself to provide the continuous data replication from the source or primary system to the target destination or secondary system. On the other hand, backup and restore rely on SAP's backup utility to create an image of the database, which can then be transferred to the target system. Each of them has advantages and disadvantages that you should consider prior to deciding what approach to use. But for the sake of this video, we will be focusing on the asynchronous replication method, and how we use the IT-Conductor platform to automate this process. Migrating applications and databases starts with understanding the source environment, or what we call the discovery stage. This is where we discover the true state of a system. It is in this stage that we determine the number of active and standby hosts, as well as the sizes of the CPU and the memory disks, to match the system requirements for the target environment that we need to build. For multi-tenant database management systems, it would be tricky to understand the nature of the source application environment, if this will be done without the use of a tool capable of linking the bits and pieces of your entire system landscape. IT-Conductor leverages a multi-layer approach to automatically discover deep dependency chains among different components in the source application environment, which then makes this stage a lot easier for you. Here you can see the different systems that are already being monitored in IT-Conductor. For this demo, we will be using the SAP HANA systems that we currently have here, the HB1 and the HOZ. Now for the next stage, or the distill stage, we need to generate performance and configuration baselines that we can use to measure the migration success. You can capture performance metrics directly from the IT-Conductor service grid, where you can see the different resource utilization for CPU, memory, and more. You can also capture the active standby count from the execution log as we've shown earlier, but you have the option to run a script from the CLI to capture the system replication state as part of the configuration baseline. And now for the final stage, we're ready to instantiate the process definition and start the migration process. We do that either by scheduling the activity to a specific date and time, or directly running it from here. For this demo, let's do the latter one and click on the Run Instantiate button here. You will be redirected to this page, and here is where you can input the activity name of your preference, and then here, you can enter a brief description of the activity, but for now, let's just type in the same. And then this one is the removal age or the removal time for the instantiated object to get deleted automatically. Then click the icon here to initiate the execution. A message box will appear to notify you that the process definition has been created. Let's click the activity link just so I can show you how it runs in the background. Notice that the activities have turned blue, which indicates that the process definition is preparing for the execution. This color will change in real time as the process executes, so you can refresh it every time. Here you can see that the Provision Azure VM activity turned orange, which signifies that the activity has already started. You can also see the status here when we click on the activity. You also have the option to click on the built-in refresh button here. Now we can see that the status changed to in progress. And when we click this icon here, the execution log will pop up. This one is a self-refreshing log, so you don't need to refresh the platform just to see the updates. You can see here that the resources are being created, and the execution log is updated in real time. You can also check the portal directly, whether or not the resources have already been provisioned. Once the Provision Azure VM activity is completed, the next activity, which is the Install HANA activity, starts automatically. In this case, we used Ansible in automating this part of the process. So here, you can see the status, the start and end time of the Ansible tasks, and when you click on one, you can see more information about that particular task execution. Fast forward to the last activity, we can see that the Replicate HANA has turned orange, which again, indicates that the activity has started. This is also an Ansible activity. So similar to Install HANA, you can check the task status here, as well as the execution log here, where you can see the logs updating in real time. And finally, when the execution completes, you will see all three activities in green. For validation, you can check the status from the service grid. You can do that by navigating to the system, expanding the replication, and from here you can see the different components, their metrics, and the replication status. Alternatively, you can verify the system replication status by running the same script we used before the migration. Data migration has never been this easy. Do you want to learn more? Feel free to reach out to us. We would love to hear from you.